Today's lesson is sum and difference identities. It's a little bit different than what we've been doing, where you made substitutions using reciprocal identities and Pythagorean theorem identities, etc. This is something that'll tell you that if you have the sum of A plus B, what's it equal to? And before you write that down and memorize it, that's not true. Okay, we're going to talk about that in a second. These are the These are the identities, okay? And it's a pattern that you just sort of have to memorize. I actually believe we give them to you on the quiz and test, but I don't remember. Anyway, so it starts out by asking you, is this a true statement? If you have the sum of two angles, these are angles, okay? So like if I have the sine of 30 degrees plus 60 degrees, is it the same as the sine of 30 plus the sine of 60? That's what it's asking. So let's stop and think. The sine at 0 degrees is 0. The sine at 30 degrees, which is really pi over 6, right, is a half. And 60 degrees is pi over 3. That's root 3 over 2. And at 90 degrees, which is pi over 2, it's 1. So if we think about this statement here, I could say the sine of 90 is equal to the sine of 30 plus 60. And is that equal to the sine of 30 plus the sine of 60? Well, the sine of 90 is equal to 1. The sine of 30 plus the sine of 60 is 1/2 plus root 3 over 2, and that does not equal 1. So that's not a true statement. The only time this is going to be true is if I have one of your angles, the sine is 0, okay? It's the only time it's true if one sine value equals 0, okay? So generally speaking, I say just no. Always use the formula. And here's the formula. You have to take the sine of one angle times the cosine of the other. And if this is a plus sign, this is a plus sign. Then you take the cosine of the second angle and the sine of the first, or the cosine of the first angle, sine of the second angle. All right? I like to do A and B instead. Sine of A, cosine B, cosine A, sine of B. If this is a minus sign, this one's a minus sign. Be careful when you get to the cosine because they're opposite. Sine same, cosine's different. If this is a plus sign here, it's a minus over here. All right, so we're going to work some of these problems so they make sense. We usually are working in radians. We usually give you things something over 12. Oh, crud. That should have been, it should be something over 12. All right, and the easiest thing to do is on the side of your paper, I make a list. And I start with pi over 6. I have pi over 4, pi over 3, pi over 2, and 2 pi over 3. And I write them in terms of pi over 12. So this is 2 pi over 12. This is 3 pi over 12, 4 pi over 12, 6 pi over 12, and 8 pi over 12. Okay? And the first thing it asks you to do is find, without a calculator, and this is important, without a calculator, the sine of 5 pi over 12. Well, I go over here and go, well, I can get to 5 pi over 12 if I add these two angles together. Because I don't know this. It's not on my unit circle. But pi over 6 is, and pi over 4 is. That's why I use these, because they're in my unit circle. All right, so instead of having the sine of 5 pi over 12, I'm going to rewrite it as the sine of pi over 6 plus pi over 4. Okay? And I know that those add up to pi over 12 because I have this running down the side of my paper. Okay? Now, the formula tells me that I need to take the sine of pi over 6 and multiply it times the cosine of pi over 4 and add to it the cosine of pi over 6 and the sine of pi over 4. That's make it so we can read that. Okay. And then fill them in. And this is what I want to see on your paper because I know you did it all. The sine of pi over 6 is a half. The cosine of pi over 4 is root 2 over 2. The cosine of pi over 6 is root 3 over 2. And the sine of pi over 4 is root 2 over 2. When I multiply, you multiply tops, you multiply bottoms, you get root 2 over 4. And this is over 4. Remember, you do multiply root 3 times the root 2. You multiply the stuff underneath and you get root 6. So my answer is root 2 plus root 6 over 4. All right? You've got to memorize the formula. Well, it's just easier to do it. Okay, this asks us to find 5 pi over 12 two different ways. I'm not going to do that. I want to jump down here and find the cosine of pi over 12. Okay, I got to get to pi over 12. I can either do pi over 3 minus pi over 4 or pi over 4 minus pi over 6. Let's do pi over 3 minus pi over 4. Okay, so I'm going to write this as the cosine of pi over, what do we say, 3 minus pi over 4. Because that's 4 over 12 minus 3 over 12 gives me 1 over 12. The formula for the cosine is cosine of pi over 3, cosine of pi over 4. If this is a minus, this is a plus. And then you have the sine of pi over 3 and the sine of pi over 4. And then you do the math. The cosine here is a half. This is root 2 over 2. This is root 3 over 2. And root 2 over 2. And I get root 2 over 4 plus root 6 over 4. And lo and behold, the same answers I got the first time, but that's the way it is. Think about the unit circle, right? You end up with the same. There's only 5 choices for your sign values. You have zeros, ones, half, root 2 over 2, root 3 over 2. Okay? So those are how those work. And the way I remember this, remember it's sign same. A plus sign in here is a plus sign here. The cosine's opposite. A plus sign here is a negative here. The tangent, you got to do this big mess. All right, next. Find the cosine of b minus a when sine is equal to 8 over 17 and tangent of b is negative 3 over 4. You got to draw your pictures. And then pay attention to the quadrant, okay? Because it tells you if it's positive or negative. So I'm going to draw my triangle for A, alpha, okay? And the sine is 8 over 17. So what's the other side of that triangle? It's one of those special ones, isn't it? Yeah, probably. Y'all are laughing at me because you already know. Is that 15? There we go. And if I draw the triangle for beta, it tells me the tangent is negative 3 over 4. Now, this one's in the second quadrant, so it's up here. So this is 15, 17, and 8. So this is negative. That one, they tell me, is in the fourth quadrant. So it's down here. So we really have, this is negative 3 and 4, and this side is 5. Okay. The formula for cosine is the cosine of beta times the cosine of alpha. If that's a minus, this one's a plus. Then I have the sine of beta, sine of alpha. And those I get off the triangle. So the cosine of beta is 4 over 5. The cosine of alpha is negative 15 over 17. The sine of beta is negative 3 over 5. And the sine of alpha is 8 over 17. So let's see, 4 times 15 is what, 60? So I've got negative 60 minus 24 gives me negative 84 over what's 5 times 17? 85. Okay. All right, they want me to find the tangent of x plus 3 pi over 4. It's another one. They gave you your angle. They tell you it's in the third quadrant. So it's down here. And the sine is negative 6 over 7. So the other side is what? 49 minus 36. This is the square root of 13, and it's negative. All right, so the tangent, what's the formula? I've got a product, a sum. So it's the tangent of the first one, the tangent of x, plus the tangent of 3 pi over 4, divided by 1. If this was a plus, then this one's a minus on the bottom. The tan of x times the tan of 3 pi over 4. So you just plug them in. The tangent of x is negative 6 over square root of 13. They're both negative, so you get 6 over square root of 13. Plus the tangent of 3 pi over 4 is negative 1. So let's make that a minus. And then it's 1 minus, and this product of that. Okay. I don't like to leave fractions in a fraction. Okay. So I'm going to multiply top and bottom by root 13. And you end up with 6 minus root 13 over root 13 minus 6. Is that negative 1? If I factor a negative 1 out of there, yeah, I think you get negative 1. That's interesting. Usually it doesn't work that nice. All right, the last thing it asks us to do is condense this. In other words, you want to rewrite that. This is a tough problem. I'm going to need more space. Let's go down here. What's that say? The sine of 3x. Sine x. I probably should have done this before I made my video so I know how to do it. Cosine of 3x. Cosine of x. Well, it looks like a pattern. You got sine, sine, cosine, cosine. Well, sine, sine, cosine, cosine is this, right? Only backwards. If you're subtracting them, if you multiply this by a negative 1, you'd have cosine of 3x, cosine x, minus sine 3x, sine x. That's angle A, that's angle B, angle A, and angle B. So it's cosine, cosine, sine, sine. It tells me it's the cosine of the two angles, and since you're subtracting them, this one has to be adding. So I'm looking for the negative, because here's my negative, cosine of 3x plus x. So that equals negative cosine of 4x. Ooh, that was tricky. Good problem. You have to recognize the pattern. And our pattern up here said it was cosine first and then sine, so I knew I had to switch these. And that's where you factor the negative 1 out front. You got your answer. Good problem. They're all basically the same. The key to being good at your homework is put this on the side of your paper. Because when it asks you to find 7 pi over 12, you go, oh, I can add these two together. They want 3 pi over 12. Well, I can just use that, except I want a sum. Well, 3 pi over 12 is pi over 4, and you wouldn't need to do it. I know they like 5 pi over 12. That's why I include this. 8 minus 3 gets you to 5. Or 11 pi over 12, you can add those together. All right, so put this on the side of your paper, do your homework, and ask me if you have any questions.